A warm welcome. This is Control Systems course lecture 5.1 representing the concept of state variables. State variable is an analysis which is carried out in order to analyze the system stability as well as to design the system with various uh, or to overcome the drawbacks of transfer function model. There are many drawbacks in the transfer function model. It is being defined only under zero initial conditions. But this is not the case of state variable analysis. The transfer function is applicable to linear time invariant systems alone. But state variable analysis is applied to time varying system as well as time invariant system also. And also state variable analysis can be applied to linear as well as non-linear systems. And one more thing, transfer function analysis is completely restricted to single input, single output system. But this is not the case for state variable analysis. It can be applied to multiple input, multiple output system also. And one more thing, transfer function model does not provide any information regarding the internal state of the system, but state variable analysis gives a perfect idea about the internal state of the system. The conventional and old method for design and analysis of the system is the transfer function method. But the drawbacks of this system can be preferably or satisfyingly overcome with the help of the state analysis. Let us start with what is state variable. A state variable is one of the set of variables that are used to describe the mathematical state of a dynamical system. Dynamical system in the sense it is a changing system. So what is the state of that particular system at any particular point or at some point? Intuitively, the state of a system describes enough about the system to determine its future behavior in the absence of any external forces affecting them. The state variable analysis can be applied to for any type of systems. In this method, it is not necessary that the state variables represent physical quantities of the system, but variables that do not represent the physical quantities and those that are neither measurable nor observable may be chosen as state variables. For example, we can have state variable analysis for phase variables, canonical variables, etc. also in addition to physical variables. So this is what is the term called state. We can see this diagram. We have a control system here. The input is nothing but U and the output is Y, and here the representation of the X is known as the state variable. So U X. With this, let us consider we have m number of inputs, p number of outputs, and n number of state variables. Normally, try to use this representation itself. For the state variables, it is n, for the output, it is p, and for input, it is m. By considering the input vector, we can say u of t is nothing but a set of u1 of t, u2 of t till um of t. Similarly, y of t and then x of t state variable. Then we have to say what is state vector. If n state variables are needed to completely describe the behavior of a given system, then these n set of state variables can be considered the n components of a vector x. Such a vector is called state vector. And state space is nothing but the n-dimensional space whose coordinate axis consists of the x1 axis to xn axis, where x1 till xn are the state variables, which is called state space.